All right, welcome everybody to another live stream. I do want to apologize for yesterday. I was planning on going live. That would have been 3 days in a row, and I think my body just told me no, I couldn't do it because by the time it was starting to get close, I just got extremely tired and did not do any work last night. Just went to bed actually a little bit early, which was kind of nice, but definitely a little unusual for me as I constantly do a lot of work, at home and at night. So what I have in store for you guys today is, or for tonight, at least for me, is to do the double and half angle formulas, the homework. This is the last homework for my students up until their second quiz, and then we'll get on to the test for analytic trigonometry. So you can see here we're going to work on one problem that is based on the triangle, and we're going to do the double as well as the half angle formulas for all of that. Then we're going to work on using the half angle formulas when given some angles in degrees as well as in radian form. Then we're going to work on simplifying some expressions when given an expression, so to kind of rewrite them as a single expression. And then we'll do some more solving here with identities for you in the case. So I also, because I was kind of scared I was going to get too tired again tonight and not be able to go live, so I didn't post anything on the Facebook. So I do apologize if there was anybody else that had some questions in there. I would like to be a little bit more consistent on that, let you guys know when I'm going live. So therefore, there's actually a little bit of ways for you guys to communicate to me as far as some certain problems that you guys would like me to address. However, hopefully we'll have some time here after this homework that if you guys do have some questions that I can go ahead and answer, then I'll be happy to be able to do that for you. We, probably spent about 15-20 minutes last time going over some extra problems, so it's kind of nice. I kind of enjoyed it, helping you guys with some work on your own that are not in my class. So I see Storms, Relax, Tariq the Grammar, T. Rasol, good to see you guys. Azan, you're back again, love it. And Monica Grumman, you are very, very welcome for everything on domain of composite functions. Azan asks, yeah, if you just were to remind me, Azan, if you have some composite or you have some two functions you like me to compose and then do the domain, we can help you out with that. But I'll definitely kind of keep that on the end. Actually, you know what I'll do? Since I am on this page, I will just write domain of composite functions. And then if you have some examples of functions you'd like me to get to, then I'll do that. I'll try to do my best. Soccer 30, hey, how are you? Arsu and Tyler, how are you guys doing? Let's get on with this work, guys. What I'm going to do is I don't want the stream to go too long. I mean, obviously, I want to get through the work. And then, obviously, what I'll do is I'll take a quick little break, check in, see if there's any questions you guys have. And I said Arsu. I don't know if that's how you pronounce your screen name, ARSU, but yes, I notice you. So what I'll do is I will get through this kind of first set, take a little break, check in with you guys, see if there's any questions or anything that anybody has on that first set, and then we'll knock out the multiple choice, and then whatever time we have remaining here, I will answer some questions. I would like to kind of do some more open streams. If you guys remember from the end of last year when we got into the quiz kind of season, I did that, kind of like some open live streams where I was just there basically to answer your questions, help you guys out. I kind of missed that. I thought that was kind of fun. It's kind of nerve-wracking for me because, like, what questions are you guys going to ask? And then, am I going to be able to find the right answer every single time? But it's kind of fun, too, because, I take it lightheartedly. I'm not a genius by any means, so I'm okay with getting something wrong or not having the right answer right then at the moment. And I think that's something that is important. You just got to understand your limits, what your strengths are. And then obviously, and just to try things, and it'll be comfortable and it'll be okay to fail, it'll be okay to get things wrong, but learn from it. And I think that's one of the best things that I've learned a lot about math is, getting problems wrong, but then learning from it and then understanding it and then not making that mistake later. Right. And I think that's very helpful as far as the learning process, and not just in mathematics, but really in anything, but being courageous enough to try it, see what happens, and if you get it wrong, learn from that mistake, and then just kind of continue going on. So, all right, guys, I don't want to ramble. This is not a rambling live stream. We got to do some math, so let's get into it, and then I'll come back and check in with you guys. All right, so in this first problem here, we're going to do purple today. in this first problem, we have cosine of u equals -2 over square root of 5. So I see the cosine of u, which represents an angle, right? Cosine of an angle. And we're kind of going back to our old form. We have it's equal to a ratio. Well, remember that the cosine is the adjacent over the hypotenuse. I don't know why I did an O there. So it's adjacent over hypotenuse. So from here we can draw a triangle, but we don't want to draw just any triangle. We need to draw a triangle that's between pi halves and pi. So let's go ahead and draw that. Now since I don't have much space, I guess I'll put it up here. All right, so here's pi halves if we're looking in standard form, and here's pi. So therefore now to go ahead and write the triangle, if it has to be in the second quadrant, it's going to look like this. We're going to want our u to be our central angle, also refer to it like as our reference angle in there. Our hypotenuse is always positive, so the negative's not going to go there. So that'd be square root of 5. Let's actually maybe zoom in there. And then this would be your -2. Okay. Now you guys can go ahead and use the Pythagorean Theorem if you like to. Or you can just kind of do, I'll just do it in my head, or I'll show you. I'll at least write out the Pythagorean Theorem, so then therefore, for those of you guys that need to follow along or have questions later, you can kind of see what I did. That's a squared, and then let's call this y squared. Okay, so when you go ahead and solve this, you'll see that that is 1. 5 equals 4 plus y squared, and then you can subtract 4, and it's plus or minus, but since you're going up in the second quadrant, you can see that y is going to equal 1. Okay. All right, so now we have basically the sides of the triangle, and now basically we have enough information now to go ahead and evaluate these double angle formulas as well as the half angle formulas. So the main important thing, though, that I am going to address with this is I'm not going to show you what the double angle and half angle formulas are. I will write them out for each one. So I guess actually I will present them. So I'm going to do at least the first one. I'm not going to write all the ones for like cosine or tangent with tangent on the half angle just because there's multiple variations, and I'm just going to do the ones that I think will be kind of easiest to start off with. So the double angle for sine of u would be 2 sine of u cosine of u. All right. So basically, if here is the double angle formula, we look at u and we say, all right, we just need to figure out what the sine is. Well, the sine is, again, of u is opposite over hypotenuse. So this would be 2 times 1 over the square root of 5 times the cosine, which is adjacent over hypotenuse, which is going to be -2 over the square root of 5. Now we're just going to multiply across. Now again, be careful. Remember, this is really a 2 over 1. It's an integer, right? So if you're going to write it as a fraction, make sure you put it over 1. And then basically as we just multiply across here, we're going to get a -4 over square root of 5 times square root of 5 is going to be the square root of 5 squared, which is just 5. So my simplified final answer is -4 over 5. Now, cosine of 2u, or the double angle formula for cosine has multiple variations. Preferably, I always like to do the cosine squared minus squared first, and then obviously when we're doing solving or identities, I usually look into different variations. But typically, the one that I've found that gives me the least amount of trouble is using cosine squared of u minus sine squared of u. All right. So now in this case, basically I can plug in my cosine of u, because remember just a FYI, cosine squared of u is equal to cosine of u squared, right? So I just need to figure out what cosine is, which I already know is -2 over 5, and then I have sine. So let's go ahead and write that in there. Cosine is -2 over the square root of 5. And that's going to be squared, and then minus sine, which is 1 over the square root of 5 squared. All right. And now we can just go ahead and square these. So -2 squared is going to be -2 over square root of 5 is 4 over 5. And that's going to be minus. This would be, 1/5. And then that equals just 3/5. Okay. So the double angle formula for tangent, if I remember correctly, I have all these. I had to write them because I'm like, usually I provide all these formulas to my student, and I didn't bring home my formula sheet. So I just want to make sure that I have that. It's, 2u, 2 tan u. So I just want to make sure I write down the correct formula here. So 2 tangent of u divided by 1 minus tangent squared of u. Okay, so that is the double angle formula for tangent. So we have our triangle, and we can see that the tangent is obviously the opposite over adjacent, which is -1/2. So all we simply need to do here is just plug in. I'm going to put over here because I'm going to work from left to right. So it'd be 2 times a -1/2 divided by 1 minus -1/2 squared. Okay, well, 2 times -1/2, guys, is just a -1. Divided by 1 minus -1/2 squared is going to be -1/2 times -1/2, which is a positive 1/4. Well, now you can just go ahead and subtract these. You could write them like this is an easy one to do, I think, hopefully. But if you get stuck, remember you can always rewrite 1 in the same denominator. So therefore you get a -1 over 3/4, and then hopefully you see you can just reciprocate that, but if you don't, then you can just multiply by the reciprocal, and then our lovely answer is going to be a -4/3, as that multiplies to give you 1. So there you go. So basically, if you have the double angle formula and you're given a equation and a ratio and a constraint, then make sure you sketch the angle or sketch the triangle in the proper quadrant based on the constraint. Find all the sides of the triangle. You're going to have the trigonometric formulas, so then just plug in those and then simplify them. All right. Now for the half angle formulas, we have this little plus or minus here. And so what that is based on is going to be, that's going to be based on the quadrant that the half angle is contained in. So that's just cosine of u divided by 2. All right. Now, again, if you think about this, like this really u represents like a reference angle. It's going to have the same value as like this angle as well. It's going to obviously have a different sign for the cosine, but it's really going to have the same value, as same ratio. So the important thing is, like, if we're looking at the half angle here, like if this is u or this is u, like the half angle is still going to be in the first quadrant. So therefore, the sine and the cosine in this example is both going to be positive. Basically, we would need these triangles to be either in the third or the fourth quadrant for the half angle to be negative. And so in this one, so therefore, since we're going to be dealing with the positive or the half angle that's going to be positive for sine, which represents the y-coordinate, right? I mean, obviously, it's still the angle u is still going to be positive here, even if you divide it by 2, because it's still in the first or the second quadrant. So we're only going to use the positive form here. And then the cosine is -2 over square root of 5, so I got to plug that in. So I'm going to make sure I leave myself hopefully enough space here. So I'm not going to write plus or minus. I'm just going to leave it as the positive. So this is 1 minus the cosine of -2. Oops, what am I doing? I'm an idiot. We already know what cosine of u is. Cosine of u is -2 square root of 5. I don't need to rewrite that. So I'm going to put this in parentheses though, -2 over the square root of 5. Zoom in. And that's divided by 2. All right. Now, I want to get rid of this radical here. So to do that, the radical in the denominator, I'm going to multiply by the square root of 5 on the top and the bottom. All right, and just make sure you put everything in parentheses because you got to apply distributive property here. So when I apply distributive property, I now obtain, it's going to be square root of 5. We can multiply these, negative times negative, so that's going to be positive. The square root of 5's here are going to divide out, so that's going to be a positive 2. And then this would be positive a 2 square root of 5. Now again, we don't want a radical in the denominator, so now I can, I wonder if I could have done that. Well, I guess we're going to multiply by the square root of 5 again, which would have been rationalizing it, which is kind of interesting. I guess I should have thought about that. Square root of 5. I guess you could have multiplied it by the square root of 25 would have been a good idea. That's kind of interesting. I haven't come across a problem like that. So again, go ahead and distribute it. Again, doing the same operation, but what happens this time, though, is now square root of 5 times square root of 5 is going to be 5 plus 2 square root of 5, all divided by 5 times 5 is 5 times 2 is 10. Now, you could go ahead and simplify this. We could break this up. I'll show this over here. I think this would be a simplified version. I'm not sure if anybody would actually want to do this, to break this up and do the square root of 10, which you could do, and then you could obviously go ahead and rationalize the denominator again if you really don't want fractions with radicals, if you're like really, really against that. I'm not really sure if this would be considered more of a simplified answer, but I guess it could be. So this would be square root of 10 times 5 plus 2 square root of 5. And there you go. So that's another variation, from there. So if that's not an answer, you can just realize that you can keep on breaking up that radical to get that radical off the denominator. All right, for the cosine, very similar to the sine. The only difference really is going to be it still has the same formula, or close to the same formula. It has the same plus or minus, but now it's just going to be 1 plus cosine of u divided by 2. So I'm going to skip some steps here as far as on the simplifying. We'll get to kind of the same point here. Like, obviously now we're doing 1 plus negative 2 divided by the square root of 5 divided by 2. And so now we know that that's going to equal 1 minus 2 over square root of 5 divided by 2. And if I were to simplify this, notice that it'd be basically the exact same equation, just with a minus instead of a positive. So I'm just going to save myself some time. Oops, why am I writing the exact same thing? And write this as 5, 2 square root of 5. Because it's the exact same numbers and everything else. The only difference is the addition or the subtraction. And then this weird answer that I decided to do. Okay, so there is for the sine as well as the cosine. Now let's get on to the tangent, which the tangent can have two different variations of it. And the one that I prefer is going to be the one where the monomial, or the function, just one single function is in the denominator, which would be sine. So therefore, this function is 1 minus cosine of u divided by sine of u. All right, so again, we know what the cosine is. Cosine is 1, so it's going to be minus. Be very careful when you're doing this. Make sure you're using these parentheses, because it's 1 minus, and then remember, cosine is 2 over the square root of 5. Right? And then that's going to be divided by the sine, which is 1 over the square root of 5. Okay, now obviously you can rewrite this as an addition if you wanted to. I also recognize that I could multiply by the square root of 5 again to rationalize this denominator. And when I do it this time, I get the square root of 5. That's going to be plus 2 all over 1. Well, obviously I don't need to write the all over 1, guys. I can just kind of erase that, because that goes to 1, and then that would be my final answer. And then also, probably a little bit more common would be just to write that as 2 plus the square root of 5. Okay, so that is just evaluating, you're using a triangle, so we can go using the double angle or as the half angle. Now what half angle is also very helpful for is, go ahead and using evaluating angles. And so basically, the way that the problem will be presented to you is basically to, evaluate, certain angles using the half angle formula. So in this case, I guess I really decided to do almost all the same ones. It's kind of weird. So we have negative 15 degrees. And again, you got to think about where's negative 15 degrees. Remember, because remember the sine and the cosine function have this plus or minus, right? But the plus or minus went away once I determined where the angle was, where the half angle was. So I noticed negative 15 degrees is in the fourth quadrant, right? So that means I'm going to need to use the negative angle. So it's important when we understand, when we do this problem, this represents, when we're using the half angle formula, this represents sine of theta divided by 2. Right? So what that means is that theta divided by 2 equals negative 15 degrees. All right, now when we do our formula here, so when I say the sine of negative 15 degrees equals, again, that's in the fourth quadrant, so it's not plus or minus, it's actually now the negative radical. So now this is going to be a negative square root of 1 minus, it's the cosine of theta, right? Notice the it's the cosine of u, well, in this problem. So if the formula or if the equation is u over 2 and we're looking for u, well then I got to figure out, I don't know why I use theta in this case because I guess I'm doing different problems, so I'm using theta here. So that means I got to figure out what theta is. So I need to multiply by 2 on both sides. And when doing that, I get theta, which is my u in this problem, is a negative 30 degrees. So I'm going to write the cosine of negative 30 degrees. And then that's all over 2. All right, so think about cosine of 30 degrees. That's going to be square root of 3 over 2. So in this case, I'm going to have a negative square root of 1. So cosine is going to be positive in the fourth quadrant, though. So that would be minus a square root of 3 over 2 divided by 2. And let's bring this radical down. I hate when I do that. Make sure you're covering up both of them. Okay? I guess I can zoom back in. Now we have a complex fraction under the radical. So what I like to do here is, again, get rid of the complex fraction by multiplying by 2 over 2. All right, so what that is going to produce now is, again, make sure you apply distributive property. Got to make sure we do that. So that's going to be a negative. Hopefully I'll run out of space here. 2 minus the square root of 3 over 4. And then just remember, guys, the rules of radicals allows us to split that up into 2 minus the square root of 3. Don't want those to look connected. 2 minus the square root of 3 all over 2. Or you could write that as a negative 1/2 times the square root of 2 minus the square root of 3. Okay? So cosine is, so again, that negative is the very important portion there, guys, because we're dealing with the half angle in the fourth quadrant, so cosine's negative. Here, the pi halves is in the first quadrant, or theta halves is in the first quadrant. So therefore, in this case, we don't really need to worry about the plus or minus. So when we multiply by 2 on both sides, let's use a different color. When we multiply by 2 on both sides here, we're going to get theta is equal to 2 pi over 6, which is pi over 6. Okay, so when we need to plug this in, we're going to be using pi over 6. So again, the cosine formula is very similar to the sine. We're not dealing with the half angle that's in the second or the fourth quadrant, so it's in the first, so it's going to be positive. And then this one is 1 plus cosine. So let's go ahead and write that in there. So the let's use a different color because this is kind of getting a little cramped. So let's use green. So I can say the cosine of pi over 12 is equal to the positive square root of 1 plus cosine of pi over 6 divided by 2. Now I'm going to simplify this because obviously, guys, the cosine of 6 is the same thing as the cosine of negative 30 degrees, right? They're both positive, right? And they both have the same reference angle. Just one's in radians and one's in degrees. But pi over 6 is the same thing as 30 degrees. So I really am going to have the exact same answer. I don't really need to spend my time, going through all the math again. I can just write plus the square root of 3 over 2 divided by 2 and then say, yeah, guys, guess what? It gives you the exact same answer we just previously figured out. Right? So I probably should have varied it a little bit on the homework, but maybe that was just some repetition. Would have been good. All right, last but not least is the tangent here. And remember the, what we're doing, half angles. Half angle formula for the tangent would be 1 minus cosine, right? Divided by sine, yes. So 1 minus cosine, let's just call this theta again, divided by sine of theta. Okay? So again, that is for the, I don't like that. I'm just going to erase that. So we're using the half angle, and I wrote the half angle right above here. It's right there. All right. But again, let's do it in red. So if theta divided by 2, which is our half angle, is equal to 9 pi over 12, then what does theta equal? So when we multiply by 2 in this case, we're going to have theta is equal to 18 pi over 12, which you can divide in the top and bottom by 6, which is going to be a 3 pi over 2. All right, so now let's go and look at a 3 pi over 2. So 3 pi over 2, again, is going to be the bottom circle on the bottom half in the on the y-axis. So I can write now that the tangent of 9 pi over 12, using the half angle identity then, is going to be 1 minus the cosine of 3 pi over 2, because that's your angle theta, divided by the sine of 3 pi over 2. Okay? So the cosine of 3 pi over 2 is obviously going to be 0. So this is 1 minus 0 divided by the sine, which is negative 1. So 1 minus 0 is just 1. 1 divided by negative 1, guys, is just a negative 1. All right? All right. We're almost done, guys. We got 2 more problems here, and then I will take a little break and kind of see whatever else you guys have. I hope you guys are being well behaved here in the chat. Probably not, but whatever. Okay, well, if you guys do have any questions on here, I do apologize. I just want to make sure I can focus and get through the rest of this, but I will kind of go back up through the chat and kind of see if there's any questions in specific to this. And then anything outside of this, I will address after the live stream is over. Okay. So let's go into our single trigonometric expression. So we kind of did this with sum and difference formulas. And this one, I just decided to do some problems where you couldn't actually evaluate. So the question is not saying you don't evaluate. It's just saying basically like, what formula do I have? And, then can you just write it as one single trigonometric expression? So I notice I have the radical. So it's going to be the sum and difference here of either cosine or sine. And really the main difference, guys, is the subtraction, negative or the positive, right? Or subtract or difference or sum. And you can see here that we're finding the sum. So this is adding. So therefore, this is going to be the cosine of the half angle formula. The main important thing you need to remember on this, guys, is that it's if you're doing the half angle, u over 2, then we're using u inside of the function. So, and again, the positive or the negative doesn't really affect what the angle is. That just affects like which quadrant that half angle would be in. Since we have a variable x, we don't really know what x is going to represent. The only thing we know is, let's just say if u is then equal to 10x, then u over 2 then is equal to 5x, right? So this is a representation of cosine of 5x. And again, if I was going to say use the half angle formulas for the cosine of 5x, you would say, okay, well then u over 2 equals 5x, u equals 10x, and then I'd have to say also that like u over 2 is in the second or third quadrant, and that's why you'd make that negative. But basically, just to write this as one single trigonometric function, you would use cosine of 5x. Same thing over here. Obviously, I can see that this looks like the tangent, and that's actually the other formula for the tangent, which is sine of u all over 1 minus cosine of u. So it's basically just that, or 1 plus, sorry, of that reciprocal function there. So you can see this represented as a tangent. But again, this is the half angle formula. So if u equals 6x, then u over 2 is going to equal 3x. So then this would just be a case of tangent of 3x. Okay? All right, so now let's get into the solving. You can see it's very explicit that I basically want you to use your double angle formulas. I can't solve these as they are and then divide by 2 like we did in the solving trigonometric equations homework, because I have more than one function. So since I have more than one function, like what we learned in Algebra 2, it's the best bet to get everything to the same side. And then it's also preferred that we use our identities to simplify the cosine and the sine. Now, for this first one, cosine, we have a lot of different variations we could use for cosine. And my recommendation, for students is I like to use the cosine squared minus sine squared first. And then if that doesn't work, or, I'm getting stuck, then I use the next identity that is going to be the same function as the rest of the equation. And so I don't if I already have cosines on the right side, then I'm going to still try to keep it consistent with cosines. If I already have sines, then I'll keep it consistent with sines. However, typically I like to always just try using cosine squared and sine squared. So let's do cosine. So cosine of 2t using the double angle formulas is cosine squared of t minus sine squared of t equals a negative sine squared of t plus 1. And so therefore, as you guys can see here, when I go ahead and solve to get everything to the side to isolate a trigonometric function, when I add my sine of t, those actually are going to add to 0. So I'm just left with a cosine squared of t equals 1. Well, to get rid of the squared, I'm just going to take the square root. Please remember to, since you're introducing the square root, you got to make sure you include plus or minus. So that equals plus or minus 1. Okay, so let's go back and look on the unit circle between 0 and 2 pi and think about when is cosine equal to positive 1 as well as negative 1 between 0 and 2 pi. Now, I wrote a bracket here, and I'm not sure why that is, but typically let's do this as a open bracket at 2 pi. So therefore, cosine is equal to 1 at 0 and negative 1 at pi. So therefore, my solution set will be at 0 and pi. Okay. The next one. So again, we see this double angle formula. So therefore, I'll do 2 sine of x cosine of x. I'll just use the identity first, and then equals square root of 3 sine of x. Now, a big mistake that a lot of students want to do is they want to divide out the sine of x, right? And we don't want to do that. Do not try to solve this by dividing out. We need to get our terms to the same side. So simply what we can do is just subtract the square root of 3 sine of x. So minus the square root of 3 sine of x. So now we have 2 sine of x times cosine of x minus the square root of 3 sine of x. Okay, and again, just a reminder, if you would have divided by the sine of x on both sides, you would have been left with the cosine of x equals the square root of 3 over 2, which is still going to leave you a solution, but you'll see why this is a problem. Okay, so you can see why this is going to be a problem later. So when you divide by sine of x, you're still going to get the remainder. You still will get a solution, but you'll see what happens here. So this, again, equals 0, right? So you can see here, what technique should we use? Well, we have common terms, common functions here in both these expressions of a sine of x. So I'm going to factor out a sine of x. And therefore, that's going to leave me with a 2 cosine of x minus the square root of 3 equals 0. So now I can use the zero product property. So I have the sine of x equals 0, and then 2 cosine of x minus the square root of 3 equals 0. So when I solve this here, cosine of x equals the square root of 3 over 2. That's exactly what we had here when we divided, right? But the problem is, when we divided, we only got that cosine of x square root of 3. Like, we divided out the sine of x, right? You literally, by dividing the sine of x on both sides, you got rid of it. And you notice when we solve this by factoring, sine of x equals 0 is actually a part of your solution set. So that's why we don't want to divide that out. So let's go and look into our answers here. So when is sine equal to 0 on the unit circle? Well, sine is going to equal to 0 at pi halves. No, it's not. Sine is equal to 0 between 0 and 2 pi at 0 and pi. Same solutions as the last problem. So we have 0 and pi. And then cosine is equal to square root of 3 over 2 at pi over 6 in the first quadrant and 5 pi over 6 in the fourth quadrant. Okay, all right. I just kind of need to take a little break here. 10:06. All right, we're looking pretty good. Why do I have comments, ladies and gentlemen, that I need to approve or hide? That is what I want to know. And obviously, they're pretty obvious. They do not need to be shown. So thank you for taking the time on posting stuff that should not be typed in, that nobody needs to go ahead and review. But I thought this was like a math help live stream. Like, crazy. Oh man, that's there's a lot coming in here. Not from you guys. Thank you. So, yeah, immature. Jeez, man, you guys, zero product property. Daniel, Sam, Nye. Oh man, I guess Andrew Stewart. Does anyone who wants to play Fortnite? That would be a great idea. Probably better than trying to do your math homework the night before your quiz. I'm talking to you guys, my students. Will there be any time to ask questions unrelated to double angle and half angle problems? Yeah, I hope so. We'll go and see. I see if so. If you have some questions, feel free to type it in there, and I will go ahead and take a look. Christina DeMarco, soccer. How are you guys doing? Advanced also the great. All right, I got a quiz tomorrow. Yes, you do, Jacob. Study up. You got this. All right. Cool. And we got Mo from Australia. That's awesome. My cousin lives in Australia. We got Ben, Nye, Gibson. Cool. Seeing guys. All right. Just trying to like read these as like skim these as best I can. Very happy to help you out, Jerry and Mathia. Kept saying perfect timing of this video. Awesome. T-Rawl. Good to see you guys. All right. Just had to make sure I said hi for you guys. And then I was wondering if you have any detailed videos on domain. Yes, Azan, if you look at my playlist, as far as on composite functions, I have a ton of videos on how to compose two functions and then find the domain. That's under the pre-calculus tab on my channel. All right. So I want to get through these multiple choice, and then if you guys have any questions, go ahead and feel free to let me know. And then I'll answer some of these questions that I see that are kind of coming in, but I don't want to spend too much time on them. I just want to get through the work that the students want. And then my calculator. And then what I'll do is I'll come in and get some of your guys' questions. All right, so find 2 theta, tan equals -1. So again, guys, this is one of those triangle problems. So we know that tangent is opposite over adjacent, so it has to be a comparison of something. Sine is less than 0. And now we don't know if the negative is, -2 or 1, but we know it has to be less than 0. So it's either going to be in the fourth or the third quadrant. Well, since sine is the y-coordinate is negative, then, since here, this would be a -2 over -1, and here it'd be -2 over 1. So you can see, obviously, this would not give you a -2. This would give you a +2. So here is the triangle we're going to work with. I can quickly use the Pythagorean Theorem here to get square root of, so 4 plus 1 is 5, so it would be square root of 5. And then it's just asking us to find the sine of 2 theta. So therefore, sine of 2 theta, now we got to use the formula. So that's going to be 2 sine of theta times cosine of theta. So that equals 2 times sine, which is going to be opposite over hypotenuse. So that's going to be -2 over the square root of 5. And then times the cosine, which is 1 over the square root of 5. So this is very similar to the problem I did. So this is -4 over 5, which actually is the exact same that I did. I guess the exact same triangle, right? Just a different representation. Next one says find all the solutions to the equation on the interval 0 to 2 pi. So again, we have a equation. I'm going to want to get these to the same side as well as use the double angle formula. So I'll say 2 sine of x cosine of x plus sine of x equals 0. So again, kind of very similar to the problem that I've already done here. I did not do that on purpose, by the way. All right, so in this case we have sine of x is equal to 0, and then we have cosine of x is equal to -1/2. So my solution set is for sine of x equals 0 is 0 and pi, And then for cosine equals negative 1/2, that's going to be in the second quadrant, which would be 2 pi over 3. And the third quadrant, which would be 4 pi over 3. So let's see if anything has that solution set. Here, right here, C. Cool. All right, find the exact value using the half angle identity. Notice that's negative, right? But remember, that's negative would place it in the fourth quadrant, and cosine is still positive in the fourth quadrant. And then none of the answers anyways have a negative radical, so we're still good. But just be careful. Just make sure you know when that u is. So if u are negative, if u over 2 is equal to a negative pi over 8, then u is equal to, multiply 2 on there, is going to be negative pi over 4. So the cosine formula is going to be square root of 1 plus the cosine of negative pi over 4 divided by 2. Negative pi over 4, guys, is in the fourth quadrant, so therefore it's still going to be positive for a cosine, so that's going to be 1 plus the square root of 2 over 2 divided by 2. And then if you go ahead and simplify this like we did, I believe I already did a problem just like this, I think. If not, I guess I'll just do it since I'm already going live and doing this. And now you can break up that square root of 2 plus radical 2 over the square root of 4. And then you can take that 4 and rewrite it in front, so we get answer C. All right, last one. Find the exact value using the half angle identity. So again, the same kind of thing. So therefore, let's just take u over 12. U over 2 is equal to pi over 12. So therefore, u is equal to pi over 6. So the sine formula, though, is a little bit different than cosine. Again, pi over 12 is in the first quadrant, so therefore everything's going to be positive. So that's going to be 1 minus the cosine of pi over 6 divided by 2. So cosine of pi over 6 is square root of 3 over 2. So it's 1 minus the square root of 3 over 2 divided by 2. Multiplied by 2 on the top and bottom. And I think you guys already kind of get the idea here. Looks like that's just going to distribute, so it's going to be a negative, so that should be a 2, and then it's going to be C again. So did I get like last homework, everything C? No, almost. So D, C, 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 C. So a lot of C's. But be careful, not everything's always a C. So there you go, ladies and gentlemen. That is the homework for double angle and multi-angle. Hopefully that has helped you out. If you guys have any questions, please feel free to let me know about them, and I will be happy to address them. For a little bit of the time that I have remaining here, I will see if there's any questions that you guys have that I can maybe answer for you. So I got domain of composite functions, which I can do an example of. And then let's see if there's anything else. Want to help me with pre-calc? Well, Legend, that's what I'm teaching is pre-calc. So hopefully all these live streams that I'm doing and all the videos that I'm making and uploading will help you with your pre-calc. Or at least, I mean, obviously you could be going over some different topics. But if you have something specific that you are covering in your class that maybe I haven't covered in mine, then feel free, and I'll be able to see what I can do to help you out. We're good noodles, Miss McLogan. Thank you. I like noodles. We're good noodles. That's good. I like noodles. That's awesome. Francesco, Andrew, good job. Glad you took the time out, Andrew, to respond. Sam McLogan, that's right. You got to represent. All right. So Vincent asked, why are you good at teaching? I am not good at teaching. I have just done a lot of problems. So when you do a lot of problems and you practice, you start to see a lot of common mistakes that you have made, and as well as that other students are making. And I believe that has been one advantage that I do see that, or I do have experience with, is, that has helped me out with teaching. I also think that has also helped me as a teacher is math didn't come easy to me when I was learning it. So I, even though it might not always come out to students in my class, but I do really feel like I do have a lot of compassion for people not understanding, math. I don't feel like you either have a math brain, you're either good at this stuff or you're not. I really do believe that you can learn this stuff if you're willing to put in the work and ask the questions. So I think being that type of student that had to work hard to, get a decent grade or get a good grade, allowed me to kind of look at math a little bit differently than, maybe some other teachers that, always were just good at math. So they liked math. I mean, of course, when you're good at something, of course you like it. I didn't like math for a very, very long time because I wasn't very good at it and I didn't understand a lot of it. So me and math had a kind of love-hate relationship for a very long time. And then obviously once I, learned some skills to be better at math and I got the kind of ball rolling, then I really, really started enjoying it and obviously decided to become a teacher. Well, cool. You got a test on this tomorrow? Awesome. Oh, I guess I scrolled down way too far. All right, Azan's got a question for me. If f of x root function and g of x equals 2, determine domain of f of g of x. Awesome. I'll be able to do it. I can do that for you. And then... And you just say, where are you from? I am from Jacksonville, Florida. Rutan says logs. Yeah, I'm not sure what you want me to cover about logs. I can do a lot of things on logs. And how do you do polynomials? I have no idea what you're talking about with how do you do polynomials. If you have a question about something with polynomials, let me know and I'll be more than happy to answer that for you. And Brandon is asking, are you trying to do, is that the derivative? Yes, that is... The derivative of x squared is 2x. Yes, thank you very much. That's good. All right. So I see. What are you looking for me to do? 1 plus I raised to the 5. Are you looking to Aldo? Yep. Sorry, you don't get your stuff presented. I see. What do you want me to do? Do you want me to expand that? Convert to polar form and rectangular form, vice versa. That is not something we have covered in my class, and not something that I've covered in a while. So therefore, I would not be able to do that and front without going back and reviewing. So apologize for that, but that's not something we are going to cover. Converting between polar and rectangular form, but not in complex units. So unfortunately, that is. Not something I will have or be able to do for you, at least on this stream. And g of x is, let's kind of make something with x minus 2. Oh, square root of the function and g of x equals x minus 2. So you want this to be a double square root? Oh, okay. So the derivative of the 2 is to infinity. Okay, so you have x minus 2. Gotcha. Okay, well, there's a couple different things to look in with this. Even if you were going to do a composite function of this, just remember when you're doing a composite function of f of g of x equals, so again, what this represents, what this means is basically plugging in the g of x function into the f of x function. So if we were to look at the f of x function, let's just say square root of x. I believe that's what something you had, right? Root function. So that would be g of x into g of x function, right? So now we can plug that into it, right? So we now know what g of x is equal to, which is going to be the square root of x, which would also be the square root of x minus 2. Okay. Now, a couple different ways you could, look at this. You could also look at this in terms of radicals or, whatever else. But the main important thing is we have two restrictions. And basically when you're doing the domain of composition or you're doing the composition of two functions, there's two things you need to consider. You need to consider the domain of the function that you're inserting into the other function. So we need to figure out what this domain is. And then you need to figure out if there is a domain of them simplified or if that has changed at all. Okay. So let's go and figure out what the domain is of g of x. And obviously, if we look at the g of x function, if you remember for any radical, we basically want to set the radicand greater than or equal to 0. And therefore we can solve, and we could say x has to be greater than or equal to 2. Right? So all numbers that are greater than 2 is going to be the domain, or we could write that as 2, infinity. So when you're doing composition, you need to take the restriction of your insert of your function that you're inserting into the other function, as well as now the domain of them together. But if you look at what's happening is when I take this function and I plug it under a square root, well, what is the only restriction of the square root? It has to be greater than or equal to 0, right? So as long as my values are larger than 2, that's going to make this positive. And as long as this is positive, I can take the square root of it. Well, that's going to make that positive as well. So the only restriction is going to remain, which will be 2 to infinity. So that is just a restriction of g of x, and that is a restriction of my composition of functions, 2, infinity. I'm not sure what you mean, Orchard, with the composition of functions, but obviously it's been over past with the limit, so I don't want to cover too much going back into limits, because I like doing limits like when I'm doing my calculus work. When I was teaching it last year, like you get right into the mood, and like I was going through it, and now I've kind of like not teaching it all this year. I'm like, oh my god, it's, even though I did so much of it, I'm sure I could probably figure out, it's probably not something that I still am like reaction, like cat reflexes on, that I feel comfortable going through on at least on a live stream, because it's probably going to take me just a couple minutes to like think through things and remember some of the stuff that I taught. So I'm not sure what the composition of functions with the limits, but typically, if I think I'm actually remembering correctly, you would again kind of apply the same operation, apply your limits of your you can just apply them one by one as far as you inputting them. And now I'm actually kind of remembering those problems, but I don't really recall exactly, some of the rules or some of the things I needed to do. Orange Mats, yes, that is correct. I do have I love that video. I think it's very helpful as far as the unit circle. So wow, radical over another radical. I've never seen that done before. And yeah, I mean, and again, like the same thing is like, what does a radical over a radical mean? Well, again, guys, like the main thing is, I mean, remember, don't confuse yourself. Like square root of x, remember, is x to the 1/2, right? So the square root of x is just x to the 1/2 raised to the 1/2. And remember, like the rules of exponents, x to the a to the b is just x to the a times b. So that's really the same thing as, x to the 1/4, right? So kind of like the fourth root there. So just remember, some of those things, like it doesn't, like that's not usually a notation that we use very often, but definitely we can go from there. So if f is x squared, if fx is x squared and g of x is the root function, determine the domain of g of x. I'm not doing your homework, am I? All right, I'll knock out one more of these, but it's the same process. F of x is x squared, right? G of x is the root function. Okay, again, before you can plug them in, you have to determine the domain. So you don't really need to worry about the domain of g of f of x, because you're plugging in f of x into g of x, right? You're doing f of g of x. So you got to figure out what the domain of your inputting function is, which it has to be all positive numbers. That's 0 to infinity. Now when you plug f of g of x into there, what you're going to get is a square root of x squared, which is just equal to x. Now we got to look at the domain restrictions of x, which there are no domain restrictions of x. So I'll put that over here. So we're good there. So there's no additional restrictions here on x. However, we can't forget about our original restriction of the square root of x. So the domain here is 0 to infinity. So even though the simplified version is non-restricted, since we are using composition, we have to include that original restriction there. Shaking my head, finessing homework answers, Jacob. Yes. Get that homework done, and then obviously, guys, tomorrow we'll definitely have some time to state to answer some questions as well over this homework or over anything else. I can't pronounce Mathilia. Can you state the differences between the law of sines versus cosines? Well, I mean, I can write out the difference, like law of sines and law of cosines. We're going to be getting into that like very soon next week. I guess there's a good video that I could make on this, but basically, we want to use the law of sines and law of cosines. The main important thing is, when we want to use the law of sines, we got to make sure we have an opposing angle as well as a side. So basically, when we're looking at that, we're looking at having like a, angle, side. Or also you could have a, let's see, what was the other one? Actually, I don't even remember these. We're going to cover this like in very soon, so now I'm kind of going off the top of my head. Let's think it here. So here's your angle. So you could have angle, side, or you could also have an angle, side angle is not going to, angle, side angle, or you could have a side angle. That would work. Side. No, that doesn't work. That was for the law of sines. That's the side angle, which is your ambiguous case. And then also for law of sines, you can use that for the side. And then, so what is it? The side angle? No, it's the angle, side angle. No, it's not that one. Yeah, it's the angle, side angle. That's it. Angle, side angle. Because the angle, side angle, because then you have the two angles and you can figure out the third one. So basically, just to give you a quick little rundown, you're going to want to use the law of sines when you have a triangle, when you have the angle, side, or angle, side, angle, or the law of cosines when you have side, angle, and side. And again, I apologize if for whatever reason I'm saying or getting that wrong, because I haven't completed fully my notes yet, so I'm just going off of the cuff, so of course I could be mispronouncing something and going from there. All right, let's see. Now, I just don't understand how you have to consider the restriction on g of x. Well, what do you mean? How can you not? All right. Let's think about it this way. Composing, so I'm going to go back to this question by Azan saying, like, why is there still this restriction here? So I guess, here's kind of like an example that is kind of a little odd, but let's pretend, I don't know if I should... But either way, I think I was talking about this. So let's pretend f of x is mom and here's dad. And dad has red hair, right? That is the square root is his gene red hair, right? Well, and obviously when they have a kid, that red hair doesn't go away. Like that gene is still there, right? You are the product of your parents' genes, right? Like you just can't forgive like, oh, I didn't show it. Like I have brown hair, but that doesn't mean you don't carry that recessive gene, right? And so it's not really like school appropriate, but I think that was one thing I remember talking to my students was like, think of like that restriction as like, it's a restriction. Like let's say, and I think I was telling this because, my wife's dad he had red hair, really, really red hair. And my wife has dark brown hair. So and her mom has dark brown hair, right? So her dad, obviously he's has his restrictions, right? He has red hair. And then obviously my wife, she doesn't have red hair at all. But again, she's still carrying her dad's gene of red hair. Like you just can't omit it and say, oh, that gene never happened or it's not there anymore because she doesn't have red hair. No, she still has that gene. So I don't know. Sorry, that's the first thing that came to mind. Hopefully, maybe that makes sense for you. Mr. McGlone, that was saying to me. He wasn't saying he wasn't finessing my answer. Oh, can you show the difference between square root and cube root? What do you mean? This difference between the square root and the cube root? We can look at the graph or the square root. So the graph, here's the square root, and here's the cube root. Something close to there. Square root of x, and this would be the cube root of x. Now, the difference is the square root is basically asking yourself, what number multiplied by itself, like twice, multiplied twice, is going to give you that value. So, for instance, like 4 is equal to, you can break this up into like a factor tree, square root of 2 times 2. So you can just say, since you have a grouping of a number multiplied by itself, then you can just see that answer is 2. Whereas a cube root is basically what is the number multiplied by itself 3 times. So let's just take the number 8. Well, we can break that up into 2 times 2 times 2. And then, therefore, you can see now we have a grouping of a number multiplied by itself 3 times, which is answer 2. Okay, and obviously we could expand upon this very much with different numbers. Covenas is, what grade do you teach? I teach pre-calculus, so I have anywhere from 10th and 12th graders. All right. There we go, ladies and gentlemen. I think, 10:30. I just put in an hour. Hopefully my video has helped you out. You guys have some questions. Sorry, I'm going to have to end questions now. Get off. I still got some things I got to do for tomorrow. So I'm going to finish this up here. But hopefully that helped you guys out. And I will be back next week we'll go over the quiz answers. So therefore you guys can help you out. And super sorry, guys. I'm going to have to finish off with the questions. But what I will do is, again, if you guys haven't gone to my Facebook, I would recommend at least during that, and then we can adjust from there. But what I'll try to do is I'll try to make sure I let you guys know of the next live stream, at least on the Facebook page, and try to schedule it as well. But I like Facebook at least for the fact that you guys can type in some questions a little bit easier than on YouTube. So therefore, what I'll do is I can post that, and then I can check those before I actually go live, and therefore I can address those questions for you guys first. So I will go ahead and take care of that. But you guys go ahead and have a great evening, and I will see you guys next week.